All right, folks, this might be a bumpy ride. I highly encourage you to slow down, pause, rewind, watch this one again. This, I'm gonna go through it. I'm gonna explain it. We're gonna do examples, but you may have to slow it down and work on it at your own pace. So feel free to pause it at any point, rewind it, listen to it again, try it again. But this one might be sticky. So let's find out. We are going to do this one again in two parts. We are going to work on writing equations writing equations first for given input values, and we're going to see what we can do from there. We'll do identifying independent and dependent variables in a different lesson. All right, so we've been given equations and been asked to create tables in the past. We've been given equations and asked to create graphs. Now we're going to be given a table, and we're going to make an equation based on that table. Now remember that equations are going to be written in the form y equals something. And we're going to try and figure out what that something is. So an equation is a function, a function, and it's going to tell us that given an input value, we get some kind of an output value, like that function machine. We got to figure out what the equation is that's inside the function machine. All we know is what's going in and what's coming out. And we got to figure out how to get there. And that's much more real world applicable. It's much more real world because we know what should happen and we know our starting point, but we don't know how to get there. We know that we want global warming to stop, or global change, or climate change, whatever you want to call it. We know we want that to stop, and we know where we are now, but how do we get there? We know we want to have lower emissions out of our cars. We know that the engines need to be more fuel efficient. Okay, how do we get there? Same idea. This is a much, much easier example, but it's the same idea. It's the same type of thinking. 0 goes in, 3 comes out. What's the only way to get from 0 to 3? Well, you can't times 0 by anything and get 3. So the only way to get from 0 to 3 is by adding 3. So go ahead and put y equals and a plus 3. We know there has to be a plus 3 because 0 plus 3 will give us 3. Now let's check the next one. 1 goes in, 4 comes out. Is 1 plus 3 4? Yeah, 1 plus 3 is 4, which means that if we take our x value and we add 3 to it, we should get the y value. So let's see, if x is 0, 0 plus 3, yep, that gives us 4 for y. That works. All right, let's try the next one. If x is 1, 1 plus 3. Oh, sorry, I put 0 plus 3 and got 4. So 0 plus 3, I get 3, which is what I wanted, 3. So let's try another one then. The next one, 1 plus 3 gives us that 4. That's what we want. 1 goes in, 4 comes out. Good. Let's try the next one. We try 5. Or 2. Sorry, 2 goes in. We want 5 to come out. So if I put 2 in, 2 goes in for x. 2 plus 3, I get 5. Perfect. And of course, same thing for the last one. If you plug in 3 plus 3, you'll get 6. So our equation for this table, y equals x plus 3. Try another one. So we've got t and d. So we know that it's going to be d equals, just like if it was x and y. You can pretend that was an x and that was a y. But in this case, they changed the letters on us, d and t. If 0 goes in, -1 comes out. So what's the only way to get from 0 to -1? Well, the only way to get from 0 to -1 is to subtract 1. It's the only way. Only way to get from 0 to -1 is to subtract 1. So we know there has to be -1. Let's check the next one. Is 1 minus 1 2? No. No, it is not. That makes things harder. So it didn't work to just subtract 1. But we know it has to be -1 because there's no other way to get from 0 to -1. So we have to ask a different question. Instead of 1, let's ask what would have to be here. And I'm going to go ahead and do something. Instead of 1, what number would have to be in that white space so that if you did that number minus 1, you'd get 2? That was confusing. I'm going to say that one more time. We don't know what this is. This is this white space. But some number minus 1 should give us 2. Well, 3 minus 1 is 2. So I know that this has to be 3. The only way to get this to work is if this is 3, right there. Okay, but it's not a 3, it's a 1. So how can I want to force it to work. I know it has to be a 3. How can I make this 1 turn into a 3? And I can't add or subtract. There's no adding or subtracting at this point. What's the only way to make that 1 into a 3 without adding or subtracting? Well, the only way to do it is to do 3 times 1, right? So if I do 3 times 1, I get 3. Minus 1 gives me 2. So that worked. Let's try the next one. If I do, so I'm going to maybe, just so that you can see it here. So we said we would do 3 times 1. Minus 1 gave us 2. Let's try 3 times 2. Well, 3 times 2 is 6. And 6, if 6 was here, 6 minus 1 gives us 5. And that's our result. That's what we're hoping to get. Because here's 5 right here. So we want D to be 5. 6 minus 1 gives us that 5. So it looks like if I take 3 times x, 3 times my value for x, minus 1, I'll get my D value. Let's take a look. So if I do 3 times x minus 1, I should get, oops, sorry, not x, t. 3 times t minus 1 gives me my D value. Let's check the last one here. If t was 3, D should be 8. So if t is 3, D should be 8. 3 times 3 is 9, minus 1 is 8. So my equation for this table is going to be 3t minus 1. And that's my equation. Give these two a try on your own. Come up with an equation that works for these tables. I'm assuming you paused it. I'm assuming you tried it on your own, but I really, really, really need you to try this on your own. Don't just wait for me to do it, because there's no system here. There's no formula. You just have to think, and that can be really hard to do. All the problems will be slightly different, so just following my examples won't necessarily get you there. You have to try it on your own first and keep thinking. It's not easy, but you can do it. I'm just going to write down the answers, and then there's going to be a link to an explanation of those answers. The equation for this one is going to be y equals 12x. The equation for this one is going to be, and oh shoot, now I got to remember it. It's going to be 4x plus 1. Y equals 4x plus 1. And so again, if you got those answers, great, you got it. If you didn't get those answers, then I want you to click on the link, and I want you to go look at the explanation. Okay, use the table to make a graph and write an equation. All right, so we've got this table. We can make an equation for that table. And again, I'm just going to write the equation, and I'm going to let you go to the link if you get it wrong. But we've got this table. We can write an equation for that table, and it's going to be y equals x minus 1. So if you got the right equation from this one, then great. If you're not sure where that came from, click on the link, and you can go see the explanation. Then I'm going to graph it. Now for the graph, I've got some points that I can use. I've got 0, -1. I've got 1, 0. I've got 2, 1. And I've got 3, 2. Now you're welcome to label those points. Because it's just going by ones, I can fill those in, and we've got 1 through 5. So I've got those points. Now, if we didn't have an equation, we would have to leave it there, because we don't know if things come in between. It would be discrete. If we just had the table and we were just plotting those points, it would have to be a discrete graph, because we only know those points. Because we have this equation, we can say, well, what happens if x is 1.5? Well, if x is 1.5 minus 1, be a half. So if x is 1.5, the y value would be a half. So there is a halfway between. If x was a fourth minus 1 would be negative 3/4. So a fourth would be negative 3/4. It would be right about there. So it does, we could fill in those points, those in-between points, which means we're going to have a continuous graph, and we're going to connect those dots. Because we have this equation, and we could fill in those points, we can make a continuous graph from this one, and it would go on forever. You could pick any number for x, and it would work because of that equation. Pause it. Try this one on your own. I'm assuming you paused it. So we're going to make an equation, and we're going to make a graph. Okay, and so we've got, sorry, I should have this ready. It should be, yeah, d equals 2t plus 2. And again, if you didn't get that equation, click on the link and see the explanation. Then we're going to plot those points. 0, 2, 1, 4, 2, uh-oh, I ran out of space. So that means that I'm going to have to rearrange my graph a little bit. I'm going to have to change the scale. Rather than counting by ones, I may have to count by twos. 2, 4, 6, 8, 10. And because I've changed the scale, I am going to label those points. Now this one I can still do 1, 2, 3, 4, 5 because that works for t. And so I've got 0, 2, there we go. I've got 1, 4, 2, 6, 3, 8. And again, because we have this equation, we can create a continuous graph from those points and say that it would go on, and these are arrows at either end because it would go on forever in either direction. Okay, try the practice problems. Again, if you didn't get those equations right when you tried it, click on the link and go see the explanation.